Hello everyone, welcome to the operating system class. See, last lecture or last video we have talked about the introduction to the operating systems and the goals of an operating systems. So in that we have talked about the OS is nothing but an intermediary device between the user and also a computer systems. Okay, and the depending on the person, the view of operating systems is different. If you ask about the students, that operating system view is different, and if it is a programmer, if it is an application developer, the view of an operating system is different. So it is called abstract view of an operating system. So the depending on the usage, the operating system definitions may change. Okay. So this is what we discussed in the abstract view of an operating systems. And when I come to this OS designer, so that operating system, it's divided into three layers, three hierarchical layers. One is user interface, and the next is non-kernel routines, and third one is kernel. Okay, so the user interface which accepts the user command, and the non-kernel routine which implement the user command, and kernel is a main core of the operating systems, and which controls the executions and also a resource allocations. So this is what we discussed in the introductions of an operating systems. And then when I come to this goals of an operating systems, so there are three goals of an operating system, that is efficient use of resource, and the user convenience, and third one is non-interference. So the efficient use is nothing but how the resources, the whatever the computer resources which is available, if it is efficiently used or not. So for that, to achieve the efficiency, the OS must monitor the resource allocation continuously. Once if it is done, then that resource must be removed from the program. So then we can achieve the efficiency, good efficiency. Okay, so this is what we talked about. We talked in efficient usage, and second one is user convenient. So how conveniently the computer systems, whatever the applications which is used through the operating systems. Okay, so how efficiently the user programs are executing. Users can access the computer resources or the computer systems. So this is what there in the user convenience. In that there are many facts are there. In many facts, some of the facts are the fulfillment of the necessity, good services, user friendly, and also a new programming model, web oriented features and evaluations. So these are the things which we discussed in the user convenience. For that you have to give us some of the example. This is one of the important question, user convenience. And the next one is non-interference. So in non-interference we have talked about the computer user can use the or can face the different kinds of interference with his computational activity. So the one program, whatever the program execution during that time, that may interrupt, that may disturbed by the other operations. So for that the OS must allocate the some kinds of resources to prevent these kinds of actions and the illegal access. So the user file cannot be accessed by the other person, so that the OS always monitors the file, the whom that particular file is accessed by. Okay, so this can be achieved through the authentications, right? So this is what we discussed in the last class. Now today we are going to discuss about the operations of an OS. Operations of an OS. So here the operations of an OS, there are the principal functions of an OS. One is program management, resource management, and also the security. Program management, resource management, and the security. So these are the main operations of an operating system. Program management, resource management, and security and protection. So that means the program management is nothing but when executing a program, when the program which is executed under the CPU, at the same time the multiple programs which is waiting for the CPU execution. So that time how the programs are managed by the operating systems. Okay, so this is one of the main functionality of an operating systems. And second one is resource management. For that execution, what are the resources are required? So that resource, if it is available, that can be allocated to the program or not. What is the status of that particular resource, whether it is available or not. If it is not available, where that particular resource which will be available, I mean allocated to the program. So these are the informations, and resource management and controlling, removing, all those things are done by this resource management. And second one is security and protection. So we know that some kinds of files can be accessed by the other persons. So some kinds of security which is required. So that security and protections are given by the operating systems. So already we have studied the security and protections through the authentications. Some kinds of resource which secure your files, whatever the files which is available. Okay. So now in detail we are going to talk about the program management, resource management and security protection. Okay. So there is a primary concerns of an operating system during its operation are the executions of the program and use of resource and preventions of interference with the program and resources. Now we are going to talk about in detail. Based on these operations, we are going to talk about the program management, resource allocations and also a security. So before going to talk all those things, the operations of OS, there are some common tasks which is performed by the operating systems. What are the common tasks which is performed by these operating systems? So please make a note, it is one of the important question. Please make a note. Okay, so this is one of the important question. Please make a note. It is also a repeated question. Okay, so the operations of an operating system, in that some of the common tasks which is performed by the operating system. So what are the tasks and when that particular task will be performed? Okay, so now the first task is nothing but construct a list of resources. So whatever the resource which is there, that must be construct, whether the list of the resources, whether it is available or allocated, what is the status of that particular resource. So that is the task, construct a list of resource. So this task will be performed when during the booting. When you are switching on your computer system or when you are switching on your laptops, that time the constructions of list of resources will be performed. Okay, that task will be performed. And second task is nothing but maintain the information for security. So maintaining the information for security. So what is that task, when it will be performed? So this task will be performed while registering the new users. When you are install your operating system, so that time it is asking about the user page, what is the user and what is the password, if you want to keep the password or not. So the multiple number of users, that time it takes all the informations, your name and then security, password, the confirmations of the password, everything which will be registered here. And verify, the third task is verify identity of the users. When it will be verified, when you are switching on to the system or when you are logging to the systems. So when your login time, that particular task will be performed. Okay, so the maintaining the information for security purposes, it will take about all your informations, name, passwords and everything and all it will take. And verify the identity of the user, when you are switching on to the system or login to the system, that time this task will be verified or it will be performed. And the next one is initiate the executions of the program. So we know that program executions will be performed whenever it is required, whenever the user required. Okay, so at the user command. So based on the user command, this task will be performed. Initiate the executions of programs. And the next one is maintain the authorization information. So authorization information is nothing but the security informations. Okay, so when that particular task will be performed, when a user specifies which collaborators can access what programs or data. So the user must be tell which are the customers can access the what kind of data. Okay, so that time this task will be performed. And the next one is perform the resource allocations. So the resource allocations, when it will be performed, when executions of the program or the request from the users. Okay, so the resource allocations will be performed when during the program executions or the request from the user. And so the next is maintain the current status of the executions. So during the resource allocation or deallocation, that time that task will be performed. Maintain the current status of the resource. So when it will be the current status, when it will be execute, when we are allocating the operating system which allocates the resource to the program or deallocating the resource from the program. That time it will be updated. The current status of the resource will be updated to the table. So the operating system which maintain the resource table, what and all the resources are available, the current status of the resource, how many resources are available, and the current status of the resource, it also maintained. When we are allocating the resource to the program, the current status of the resource will be uploaded. I mean the -1 which performs and upload into the table. When it is deallocate the resource from the program and it is added to the particular resource. So that time the current status of the resource will be performed. And maintain the current status of the program and perform the scheduling. So this will be performed it will be performed continuously during the OS operations. The current status of the programs and also perform the scheduling strategies. So the everything which will be performed continuously whenever during the OS operations. So these are the common tasks which is performed by the operating systems. So construct a list of resource, maintain the information for the security and verify the identity of the user, and initiate the executions of the program and maintain the authorization informations and perform the resource allocation and maintain the current status of the resource and maintain the current status of the program and performing the scheduling program or scheduling strategies. Okay, so when this particular task and all performed, it is given. Okay, so make a note, this is one of the important questions. Okay, now we'll come into the operations of an operating system. The program management. The first one is program management, second one is resource management, and third one is protection, I mean security and protection. Okay, so now we are going to talk about the program management. Okay, so the OS initiates the programs and arrange their executions on the CPU and terminates when they complete their executions. Okay, first it will be initiate the program executions and arrange the CPU for the executions and terminate whenever it is completed from the executions. Okay, okay, since the many program which is exist in the system at any time, but the OS which performs the function which is called scheduling. Scheduling is nothing but it decides which program should be given to the CPU at any time. The selections of the program for CPU execution next. It is called scheduling. So you have to remember this term scheduling. In this subject we are going to keep on talking about the scheduling and resource management and all. So you have to remember what you mean by scheduling. Scheduling is nothing but the operating system which decides which program is going to execute next under the CPU, which is called scheduling, right? Okay, so the achieving the interleaved executions of program is called scheduling, which decides which program should be given to the CPU at any time. So OS which performs the function which is called scheduling. Scheduling is nothing but to select a program for execution. So which decides which program should be given to the CPU at any time. Okay. Now for example, here if you can see here the diagram which shows the schematic of scheduling. Okay, so here the boxes, the box which represents the rectangular box which represents the program waiting for the CPU. So the each and every rectangular box which specifies the program. Okay, now the set of programs are available in the queue. Okay, ready to execute in the queue, waiting for the CPU executions. Now the scheduler, the function which is called scheduler, the scheduler which selects the any one of the program from the queue, and that particular selected program which is given to the CPU, for execution. Once the programs are completed, then that particular program will send for the another execution or another performance. If it is not, that will be after some time, after the predefined time, that particular program will be removed from the CPU execution and put it into the queue again. That particular CPU which is given to the, allocate for the another program. So this is called preempted program. So the forcefully the programs are removing from the CPU execution before executions of the before completions of the program. So that is called preempted program. So if that complete execution is not completed, then that program which is put into the queue, and that particular program will be waiting for the CPU to execute. Okay, so this is called scheduling strategy, scheduling, the functions of scheduling. Okay, so the scheduler will select the any one of the program from the queue and give it to the CPU for execution. So in this scheduling also there are two types of schedulings are there. We will see in this unit 2, module 2. So preemptive scheduling and non-preemptive scheduling, like that, the two kinds of schedulings are there. We'll see in the next module. Okay, so that based on that, the program will be selected, that selected program which is given to the CPU for the execution. So if it is removed from the CPU after some time, that program which is put into the queue. Okay. So that this scheduler which specifies how long the program can be allowed to use the CPU. Okay, so that is a predefined time which is allocated to the program execute under the CPU. Once that particular time is over, it forcefully remove the program from the CPU. Okay, so the OS takes away the CPU from the program after it has executed for the specific period of time and gives it to the another program. So the CPU will be allocated to the another program. This action which is called preemption. So I have to remember this term also, preemption. What is a preemption? Removing the program from the CPU execution. It is called preemption. So that by using this scheduling policy, the scheduling functionality which is included in the operating systems. Because of this, it increases the efficiency and also user services. It increases the efficiency and also user services. However, each program would suffer only the short delay before it gets an opportunity to use the CPU. Okay, so that results will become the good user service. Okay. So if the preemptions is performed after a program has executed for long period of time, the scheduling overhead would be lesser, but the program would suffer a longer delay, so the user service also poor. Okay, so just you think over this preemption which is not there. If it is not there, then the scheduler will select any one of the program which will be allocated to the CPU. So each program, it takes a own time to execute the programs. Okay, and after that, so until that time, the remaining programs in the queue, it waits for the CPU. Okay, so that is the delay will be increased. So that time the user service will be over. So because of this preemption, the user service is also increased, the delay is also reduced. Okay, so this is all about your program management. This is how the operating system will manage the program when it is executing. Now the next one is the resource management. How the resources are allocated and how that will be deallocated from the program. So then again, the resource allocation and deallocations can be performed by using the resource table. So everything which is through the resource table. So this is the resource table, the example of resource table. Here we have a kind of resources, the printer 1, printer 2, printer 3, disk 1, disk 2 and the CDW1. Okay, so these are all my resource. For example, okay, what kind of resource it is, what class of resource it is. So these printer 1, printer 2, printer 3 and all the printer resource. And then disk 1, disk 2, it is nothing but the disk resource. CDW1 is nothing but CD writer resource. Okay, and the address, the address of this particular printer. Printer 1 address is 101, printer 2 address is 102, printer 3 address is 103, disk 1 is 201, disk 2 is 202 and the CDW1 is 303. And the next one is allocation status. So allocation status, which specifies whether that particular resource is allocated or it will be free. Okay, if it is unallocated, in which program it is allocated, where it is allocated. So that information also included in this resource table. For example, the printer 1 which is allocated to the program P1, and printer P2 and printer P3 are in free. It is not allocated, it is in free state. Okay, next the disk 1 and disk 2. Disk 1 and disk 2 which is allocated to the program P1 and program P2 respectively. It is not free. Okay, now CDW1, it is in free state. Okay, so the resource table which contains the name of the resource, what kind of resource, what class of resource it is, and then address of that particular resource, and then allocation status. So all the informations which is there in the resource table. So when it will be constructed, the resource table, already we know that the resource tables are updated or constructed when it is boot procedure, when it is booting the systems. Okay, when it is switching on the systems, so the each and every resources are updated by the operating systems. So the resource allocations are done, the resource allocation and deallocations are updated when it is allocating to the program, when it is deallocating the resource from the program. Okay, this is the resource management. Now the resource allocations are two types. There are two types of resource allocation. So one is the partitioning of resource. Second one is allocation from the pool. Okay, the resource allocation function which performs binding of one or more resources with the requesting program. One or more resource from the requesting program. It associates the resources with the program. Once if it is allocated, it is associated with the requesting program. Okay, so it is also deallocate the resource from the program and allocate them into the other programs when it is required. Okay, allocations and deallocations of the resource in this manner, which helps to implement the resource sharing by the users. Okay, so I have told you that the resource management, it is divided into, so that means allocations of the resource, it is divided into two types. One is resource partitioning and other one is pool based resource, that is partitioning of resource and allocation from the pool. That means resource partitioning is nothing but it decides before executions of the program, what and all the resource which is allocated to the program, it decides before the execution of the program. So it decides a prior what resource to allocate to the each user programs. Okay, so it divides the system resource into the two partitions. A resource partition is a collection of resources. So that resource table which contains the entries of partitioning, and it is very simple to implement. The resource partitioning, it is nothing but simple to implement but lack flexibility. Okay, so it is also called as static allocation. This partitioning of resource, which is also called as static allocation, because before going to start the executions of the program itself, what and all the resource which will be allocated, it will allocate to that particular program. Whether it is required or not required, it will not bother about that. It will allocate the resource. Okay, so this is nothing but an static allocation. Okay, so in the static allocation, the flexibility, I mean, if it is required by the for example, the program P1 which allocates the memory or also the disk and also a printer which is allocated. Okay, but it is not at all required by the program P1. That time that particular resources are all wasted. Okay, it is an ideal state. Okay, so that kind of allocations is not a flexible one, it is not a efficient one also. Okay, resource partition. And second one is pool based allocation. So the pool based allocations is nothing but the OS allocates the resource from the pool of resource. So the OS which maintains the pools of resource, that is commonplace, all the resources are maintained whenever the request which is comes from the user or from the program, that particular what and all the required resource, what and all the requested by the program, that particular resource will be allocated to the program from the pool. It is called pool based allocation. So which increases the efficiency and also a use of resource. Okay, so and also the overhead will be less in that. Okay, allocation and reallocations of the resource, the overhead will be very less in this pool based resource allocation. And it is also called as dynamic allocation. It is also called as dynamic allocation because whenever it is required, whenever it is request from the user or request from the program, that particular resource will be allocated. So it is called dynamic allocation. Okay, so this pool based approach which avoids the wastage of resource allocation. Okay, so it can provide the better resource utilization, the pool based resource. This is all about your resource management. Okay, the next. And the next one is resource management, I mean the virtual kinds of resource. So one more thing I want to discuss about, it is a virtual resource. What do you mean by virtual resource? It is nothing but an imaginary resource. It is an abstract view of resource taken by the program. It is an imaginary resource. It is an illusion based resource. Okay, and the virtual resources are supported by the operating system through the use of real resource. So the same real resource may support the several virtual resources. Okay, so it will be started with the use of virtual devices. For example, the printer services and all. When you are giving the print to that particular program or particular page, you doesn't know where it is saved. It isn't stored into the temporary storage. That is called virtual memory. So it is a illusions of main memory. So we cannot retrieve the memories where it is particularly available. So that particular the word file, whatever it is, whatever you want to print that particular document, that will be stored into the temporary storage. Okay, once it is printed, that will be erased. So it is called the virtual resource, the imaginary resource which will be provided by the operating systems. So this will use the real resource. So that same real resource may be supported by the several virtual resources. Okay, and it provides the effect of having the more resources. So that we can have the effect of more resources we can allocate to the many programs, so that the resource overhead will be reduced. So the most operating system which provides the virtual memory that may execute a program bigger than size of RAMs. Okay, and some of the operating systems which creates the virtual machines. Each virtual machines can be allocated to the user itself. Okay, so this is all about your resource management. So in that we have talked about in resource management, the resource table we have talked about, and also the allocations of resource. There are two types of the resource allocation: partitioning of resource and the resource allocation from the pool. Okay, so these are the two resource allocations we have talked about, and also a virtual resource also there. We have talked about in the virtual resource. And the next one is security and protections. So in this, the security and protections already we have talked about in the introductions itself. So the security counter the threats of interference are the illegal use of the person. Okay, so the one user resource can be accessed by the other user resource. So to avoid that, the set of resources will be allocated by the operating system. That will be the operating system will monitor continuously what are the resource, which resource is allocated or monitor or accessed by the users. So this can be done by using the authentications. Authorization, which prevents the interference with the files. Okay. So that authentication only registered users can use that computer systems. So for example, if the computer system itself, if you open the main page, you will see the user window. So in that user window, you can see the number of users. If you are an authorized person, then only you can use that particular windows. I mean, particular files you can access it. If you are not authorized person, you cannot access that particular file. If you know the password, you can access. That is the other thing. Okay. Apart from that, if I doesn't know about the passwords and all, I cannot access that particular one. So it is a protected one. So that kind of service which is provided by the operating systems. So the protections counter threats posted by the use of on OS. So the many protections in the hardware features used by the operating system to prevent the disruptions of programs and OF services. Okay, so that authorization which prevents the interference with files. Okay, so this is all about your security and protections. Please make a note, this entire topic itself one of the important question, the operations of an operating systems. So I have to write about the program management and the resource management and security and protections. In resource management, you have to write about the resource allocation, resource table, and also a virtual resource. Okay, in program management, you have to you have to write about when the program executing the program, how that operating system will manage the executions of program. Okay, so to manage the functionality, there is one of the function which is introduced by the operating system, that is called scheduling. The scheduling is nothing but selections of the program, okay, which is execute next under the CPU, that is called scheduling. So in that, the one more the term which is added, one more functionality, that is called preemption, removing the program from the CPU execution after the some time, after the allocated time. Okay, so that's called preemptions. By using the scheduling and preventions, the user functionality, user services are also increased, and the resource allocations is also increased. Efficient usage of resources also increased. And security and protections, by using the authentications, we can protect your files. That facility which is given by the operating system. So this is all about your operations of an operating system. I think at the end of this video, you'll come to know what is the basic operations of our operating system. We'll see you in the next class. Thank you.